Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and the question belongs to paper 9709/42 for the session May June 24. And we are going to solve question number 7. Let's go through the question. Two particles P and Q of masses 2.5 kg and zero point 0.5 kg respectively are connected by a light inextensible string that passes over a small smooth pulley fixed at the top of a plane inclined at an angle of 30 degree to the horizontal. Particle P is on the plane and Q hangs below the pulley such that the level of Q is 2 meter below the level of P. Particle P is released from rest with the string taut and slides down the plane. The plane is rough with coefficient of friction zero point 0.2 between the plane and P. Question number 8 says find the acceleration of P. So we have already understood the question. It's very simple. We will have to find the acceleration of the particle, and the surface of particle P is not smooth at all, it's rough. So first of all we will have to pick up the concept. We know that in such cases for finding acceleration we apply the concept of the motion law of Newton. As we are going to apply the motion law of Newton, motion law of Newton requires the driving force as well as resistance force. Since the surface is not, the plane is not smooth, it is rough. That's why first of all we will have to find the normal reaction force. So let's see the normal reaction force acting on P. For that, let me draw this. Let me draw the scenario. Okay, so this is, suppose this is our normal reaction force always acts vertically, vertical force actually. So this one and this one, and this is nothing but the weight always acts vertically downward, and normal reaction always acts vertically in term of the plane, in term of the surface. So this is 90 degree and angle is 30 degree. Here is the particle. So first of all we will have to find the normal reaction of the particle, reaction force of particle P. So for there is no upward force acting on the particle P, so R plus 0, upward force is 0, downward force is this one is the downward force. Okay, this one is the downward force acting on the particle, that means normal downward normal force. So which is what is the component of the, how can we calculate this? It is mg, m mg mg cos 30 degree, mg cos 30 degree, or R is equal to mass of the particle P is 2.5 and acceleration due to gravity is 10 and cos 30 is root over 3 over 2. Hence our normal reaction force is going to be 25 root over 3 over 2. If we divide it by 2, it is 12.5. 12.5 square root over 3 is the normal reaction force. And we have already decided that we are going to apply the concept of the motion law of Newton for finding the missing value. And you know, as there are two components to be obtained, one is tension in between the particles and the other one is acceleration of the particles. So we will have to form two simultaneous equations because there are two particles. So one after the other we will write first for particle P. Let us write for particle, for 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 particle P. For particle P, we know particle P is just sliding down like this, and the concept we are going to apply is driving force minus resistance force is equal to mass into acceleration. Let us see what is the driving force acting on particle P. On particle P, driving force is nothing but there is no external force, only weight is causing it sliding down. So this is the component of weight. Okay, this is just sliding down and weight is causing this sliding down. So what is the driving force for particle P is mg. This is in term of this triangle, this is vertical line, so mg sine 30, mg sine 30 degree, mg sine 30 degree minus, now resistance force. So what are causing resistance to this sliding down? Number one is tension, because there is tension in between the string, in between the particles. And another one is we have already calculated normal reaction force. So normal reaction force is mu r. Mu r equal to mass into acceleration. Mass of the particle is 2.5. 2.5 into acceleration. Well, after that, we are going to calculate mass of the particle P. What is how much is the mass of the particle P? Mass of the particle P is 2.5. So 2.5 into acceleration due to gravity is 10 into sine 30 is like half, minus tension minus mu. Mu is the frictional coefficient. Frictional coefficient is 0.2. So 0.2, and our R has already been obtained. R is 12.5 square root over 3 equal to our right side is how much is our right side? Right side is 2.5 a, 2.5 a, 2.5 a. Okay, well then if we simplify, 2.5 into 10 is 25. 25 over 2 means 12.5. So this is 12.5, 12.5, 12.5 minus, if we multiply 12.5 by 2, it is going 2.5. So 2.5 root over 3, 2.5 square root over 3 equal to minus, if we isolate t, we are going to isolate t to the right side, minus 2.5 a equal to, we have isolated t on the right side, and we may leave this as equation number 1. We have already explained that there will be two simultaneous equations because there are two particles and two values are to be obtained. Okay, this was about particle P. Now we will resolve the forces acting on particle Q. So for particle Q, let me change the ink. For particle Q, particle Q, the same concept we are going to apply. The concept is driving force. So driving force minus resistance force is equal to, particle Q was actually moving upward. Okay, moving upward equal to mass into acceleration. So driving force for particle Q, let's see what is causing it moving onwards. Actually particle Q is hanging just below the pulley, and due to this tension, due to this sliding down of P, Q is just moving up. So driving force for Q is nothing but the tension in the string. So tension is the driving force, tension is the driving force minus resistance force. What is resistance force causing resistance to the motion on Q is nothing but the weight of Q. It is just moving it, trying to move it downward. Okay, so just the weight, only weight is the resistance force for Q. Only weight is the resistance force causing to Q. So what is the weight? Weight is mg. We know weight is mg sine 90 degree, sine 90 degree, because you know the particle is hanging vertically, isn't it? Look, so here what is it? The angle will be 90 degree. If this one is 30 degree, this must be 90 degree. Equal to right side. Our right side is mass into acceleration. Mass of particle P is actually 0.5 and acceleration. Well, tension is to be isolated, or let me write this. Mass of the particle Q is zero point 0.5 and acceleration due to gravity is 10 sine 90 is 1 equal to 0.5 A. Then if we isolate our tension, then it is going to be 5 plus 0.5 A. So that's all about the equation number 2. Now we will solve them simultaneously. What are our equations? First equation is, let me change the ink. This is our first equation. First equation is this. This is the first equation. This. This is the first equation, whereas that is the second equation. So solving the equation simultaneously, if we write from equation from equation from equation 1 and 2, 1 and 2. So one left side of 1 is 12.5. Let me write the equation 1 first. What was it? 12.5 minus 2.5 root over 3. 12.5 minus 2.5 square root over 3. Then is there anything else or not? Yes, 2.5 root over 3 minus 2.5a minus 2.5a. And the equation number 2 was simply 5 plus 0.5a. 5 plus 5 plus 0.5a. Well, now if we simplify, negative 2.5 plus negative 0.5 means 3. It is negative 3a is equal to, in the right side there remains 5 and minus 12.5 plus 2.5 square root over 3. Well, so it is going to be, a is equal to, if we change the symbol of all of them, it is going to be, so 12.5 minus 5 minus 2.5 square root over 3. Hence our acceleration is going to be, so our acceleration is going to be, let me use my calculator. Acceleration is going to be 12.5 minus 5 minus 2.5 square root over 3 over 3. That means our acceleration is going to be 1.0566. 1.0566. If we just round it up to three significant figures, it is going to be 1.06. 1.06 meter per second square. Meter per second square. So this is what our answer should be. So what have we done here? In the whole of the solution, we have just applied the concept of the motion law of Newton, which includes the frictional force. For frictional force, we will have to calculate the normal reaction force and just simply driving force minus resistance force. But in resistance force of Q, the only resistance causes is caused by weight, nothing but the weight. So I think you have understood this. Let's move on to the question number B. And the question number B says, use an energy method to find the speed of the particles at the instant when they are at the same vertical height. Well, one thing has been suggested by the question that we will have to apply the work energy equation. So what are the components of work energy equations? We know the work energy equation is calculated on change in GPE as well as change in kinetic energy. That means difference between the gravitational potential energy as well as difference between the kinetic energies. And for GPE, we know that the component of GPE is mgh. H is the difference between the heights, initial and final heights, as well as for ke, change in kinetic energy, we require final and initial velocities. So it's all about, actually, whenever we apply work energy equation, we require two data. One is the change initial and final velocities, as well as initial and final height of the particles. So one after the other we will have to find them stepwise. First of all, let us see the figure. According to the diagram, let us draw the diagram over here. How was the diagram? Diagram was, suppose this is, here is P. Okay, this one is P, which was sliding down. Okay, let's say it has slided down x meter. Suppose this distance is x meter. Well, and here the angle at which the plane is inclined is 30 degree. Okay, so this is the distance traveled by P, but we require the height that has been traveled by P. That means initial and final height of the particle T. Suppose here this is the distance traveled by X. So the same distance was traveled by Q also. That means Q moved up. Suppose Q moved up to, if this is X, so Q have also moved up to X. And what was the total distance of this one? I mean, the distance was, it was 2 meters. 2 meters. So Q went up until X, when this point is X, and P came down to minus X meters. Okay, the final height actually. Okay, so let us the final height of particle P. So for P, it is, suppose this is H, height is H, is equal to height of, final height of P is equal to, this is X sine 30 degree. X sine 30 degree, the vertical component of this triangle, is equal to X sine 30 is equal to 2. So this is the distance traveled by, that means the P came down up to this. Okay, P came down up to this, which is X over 2, and Q went up, to X meter. That means Q from downward, from a bottom place, it moved up X meter, whereas P moved down, and perpendicular distance was X over 2. So total distance is, what was the total distance? Total distance was 2 meter. Let me show you. Look at this, the distance between them. Let me show you the figure here. Look at this. Here the distance between P and Q. Look at this. This is 2 meters. This is 2 meter. the distance between P and Q. So P moved downward and Q moved up. And Q moved up x meter. The distance traveled by P also x meter. But height and distance are not same. So please don't get confused with the height and distance. Distance traveled by P was x meter. But it doesn't mean that height of the initial and difference between initial and final height is 2 meter. No, it's not. Height is different, as I have done here. Height, the final height of particle P is x over 2, and for Q it just moved up x meter. So total distance is x bar hq. Final height of Q is suppose x meter. So x over 2 is equal to what? That is 2 meter. Total distance is 2 meters. After that, that is 1x plus half x, that means 3x over 2 is equal to 2 meters. So our x is equal to, x is going to be 4 over 3 meter. So finally, in terms of value, hp, that means height traveled by P is, that means final height of P, it must be, look at this, P was moving down, so final height must be in term of this reference value. Then initial, if it was initial, as it is moving downward, so P is having negative value. And what is the height of P? It was x over 2, x over 2, x over 2, and it must be negative. Okay, it is negative. X means 4 over 3 over 2, means it is going to be negative 4 over 6 meter. This is the height, final height of particle P from the ground. Then final height of particle Q is, it was just x, means 4 over 3 meter, and it is positive because it was moving upward. So we have got one of the components of our work energy equations. Well, now we are going to apply our work energy equation. Okay, they have already told to apply the work energy equation, and work energy equation is what? The concept is work done by work done by driving force. No, before that, I think we should find the component of them. Let us find the change in GPE of particle P. So let us find change in GPE. Change in GPE of particle P, P plus change in GPE of particle Q. Okay. So for P, we know the formula of change in gravitational potential energy is mgh. M particle M has a mass of 0.5, and g acceleration due to gravity is 10, and then mgh, h has already been obtained. We have obtained here how much? For particle A, particle P, the final height is minus 4 over 6, whereas initial height was 0 because it was moving downward. So negative 4 over 6 plus change in GPE of Q, that is mgh, mass of, I think I should write one more step. No, let it be continued. So that is M, this is mgh. Okay, no, I will have to show, I think. So let me erase this. Change in GPE is actually the formula of mgh. mgh of, that means height, final height of P, plus mgh of the difference between the initial and final height of Q. So mass of particle P was 0.5 and acceleration due to gravity is 10, and height, final height, that means difference between the height was it was moving downward, that's why it was negative 4 over 6 plus mass of particle q was 2.5 into acceleration due to gravity is 10, and height it was moving upward, so height was 3 over, how much was the height of final height of particle q? It was 4 over 3. This was 4 over 3 meter. So it is 4 over 3 meters. 4 over 3. So ultimately it is going to be 5 for negative 20. Negative 20 over 6 plus 2500 over 3. 100 over 3 equal to, it is going to be 6. So negative 20 plus 3 to the 6. Okay. So 200. It is going to be 200. Sorry, we made a mistake in writing the mass of the particles. Let's see what were the masses. The mass of particle P, look at this. Mass of particle P was 2.5. It was 2.5, and mass of particle Q was zero point 0.5. Okay, let it be inserted. It is P was 2.5. So mass of particle P was 2.5, then it is going to be 2.5. It is 2.5, whereas this one is zero point 0.5. So what is it going to be? 2.5 into 25 for 100. So this is 100 over 6. And the second one is 20 over 3. 20 over 3. It is just 20 over 3. Okay, if we now calculate, it is going to be negative 100, negative 100 minus, sorry, plus 20. So it is going to be negative 80 over, sorry, not 20, it is going to be 40. How is it 20? Sorry, it is going to be 40, because 3 twos are 6. So it is 40. If we subtract 40 from 60, it is going to be 40 minus 100, that is negative 60. Negative 60 over 6 means it is going to be 10, equal to negative 10. Negative 10 is the total change in GPE. Then we will calculate the change in KE. Okay, for change in KE, let me change the ink. This is going to be now change in KE, change in, because these are the components of work energy equation, change in KEP plus change in KEQ. Okay, so that is, the formula is half of M and final, that means difference between the final and initial velocity. So half of M, and this is for P and this is for Q, M V square Q V Q square. So let us see what was the final velocity. Final velocity is to be obtained. It is missing. Mass of particle P was what? 2.5, and final velocity is to be obtained. Initial velocity was 0, so there is no necessity of uh, you know subtraction, and velocity of each of the particle is same, so we simply write common V plus half into mass of particle Q was zero point 0.5, and velocity will be same, so we can write V square. So it is going to be half of, that means 2 is the denominator, so 2.5 b square, 2.5 b square, let us add directly. If we add up 2.5 and 0.5, so this is 3 v square, 3 v square. So this is the change in total kinetic energy, and so we have got both the values, change in total kinetic energy as well as change in gravitational potential energy. Now easily we can apply the concept as they have suggested. We are going to apply that work energy equation. Okay, so let us write work energy equation. So work energy equation, you know, the concept is work done by driving force minus work done by resistance force is equal to change in GPE plus change in KE. KE. Okay, now let's see what was the work done by driving force. Actually, if we go back to the question, yes, this is our question. What is written here? Particle P is released. Here it is written particle P is released from rest with the string taut and slides down the plane. That means there is no external force acting on this for moving it downward. So work energy equation is applicable for any external force acting on this, as there is no external force acting on the particles at all. So there is no driving force for them at all. So it is going to be 0. So driving force is just 0. As driving force is 0, so work is also 0. Well, then minus resistance force. But don't think that there is no driving force at all, there is no external force acting on the particles, that's why there is no resistance force also. No, that's a wrong concept. There may be no driving force, no external force acting on the particles, but there may be the resistance force acting on this, because look at this, resistance force is here, the surface was what, the on Q there may be no resistance force. Look at this, Q is just hanging down, Q is hanging down, so there is no resistance force acting on Q, only weight is there. Weight has already been dissolved through change in GPE. But for Q, look at this, there is a resistance force because the surface was not smooth at all. It has been written that the plane was, it is written below such that the level of Q is this. Particle P is released from rest with the string taut and slides down the plane. The plane is rough. Look, the plane is rough. That means there is a resistance force. And what is that resistance force? Resistance force is mu r. We know that resistance force we have already calculated in the previous solution. It was mu r. So what was our mu r? Our mu r was 0.2. Look at this. This is what our mu r is. This is mu r is 0.2 into 12.5 square root over 3. So this is actually resistance force. So what I was trying to make you understand, that there may not be any external force acting on the particles, but there may be the resistance force acting on them, because the surface of the plane is rough. So our resistance force is what? The resistance force is mu r, and mu r is 0.2 into 12.5 root over 3. So let it be written over here. Our resistance force was 0.2. Let us check once again. It is 0.2 into 12.5 square root over 3. And what is the formula for resistor work? Formula of work is actually resistance force into, that is resistance force into S, and change in GPE plus change in GPE has already been calculated. Didn't we calculate change in GPE? Total change in GPE for both of them. Okay, let us write that. We can write them again. Yes, we can repeat them for better understanding. Change in GPE. So this is like the sum of change in GPE. Change mg, no, not mg. Just change in GPE of the particle P plus change in GP of particle Q. Of particle Q, as there are two particles, so we'll have to calculate simultaneously. Now, then plus change in kinetic energy, change in kinetic energy of the particle P plus change in kinetic energy of the particle Q. Well, now we do have all of the data to be inserted here. It is now resistance force. We have already calculated resistance force was mu r. Mu is the frictional coefficient, which was zero point 0.2 into our frictional force was what? Not frictional force, normal reaction force was 12.5 square root over 3. Then S is the displacement of particle P. Look at this. We are not calculating any resistance to motion of Q. So we have already explained, because there is no external resistance to motion of Q. Only there is a resistance to the motion of particle P. So we will calculate the distance traveled by Q. Distance traveled by P. Sorry, distance traveled by P. We have already calculated. This is the distance. This is the distance traveled by P. How much was the distance? Remember, once again, I am repeating. Distance and height are not same at all. Distance is the travel distance, but height is calculated from the ground. Considering the ground as reference frame, height has been calculated, initial and final heights. But distance is the total displacement P traveled. Then, so how much was the value of X? X was this. So P traveled a distance of 4 over 3 meter. Just we are going to write here 4 over 3. It is going to be 4 over 3. Then change in GP, that means sum of the change in gravitational potential energy of P as well as Q's. That this one, whole of this is, we have already calculated the change of sum of the change of GPE is what? This is negative 10. We have calculated it negative 10. So we are going to just substitute this as negative 10. This is negative 10. Plus then change in KEP. We have inserted the value of this together, because we have, prior to this, we have completed it beforehand. Then change in the sum of the change in kinetic energy of particle P as well as Q is, what was the total change in kinetic energy? It was 3v square. This is 3v square over 2. So we are going to substitute this as 3v square over 2. 3v square over 2. Now if we calculate, then how to do or what to do, we will just write here, well, 12.5 into zero point 0.2, it is actually 2.5. So 2.5 and 4, that is 10. So negative 10 over 3, and that is square root over 3, plus, if 10 is transposed to the left side, it is plus 10, and it is 3v square over 2. Well, then what is it going to be? It is going to be 30. If this 2 is transposed to the other side, what will it be? It is going to be 3v square. 3v square is equal to, if 2 comes to the other side, it is negative 20 square root over 3 over 3 plus 20. Okay, then if 3 is transposed to the other side, what will it be? 3 it is going to be 9. V square is equal to, it is 9 negative 20 square root over 3 plus 20 over 9. Then our v square is going to be, one more step can be written expanding this. So our v square is equal to 9 over, that is 20 minus 20 root over 3. No, it doesn't make sense. There is something wrong somewhere. Sorry, it is going to be 3 over 20. 20 over 3. We made a mistake. It cannot be. It is just 3. So let it be written as 3. This is 3. So it is going to be a negative 20 root over 3. Negative 20 root over 3 plus 60. 3 3s are 9, so it is going to be 60. Hence, our V is going to be, let us write, our V is going to be, or V is equal to square root over this 60 minus 20 square root over 3 over 9. Okay. Hence, our final velocity is going to be, hence V is equal to, let me use my calculator. It is going to be square root over 60 minus 20 square root over 3 over 9. Okay. So equal to, so using my calculator, I got that final velocity is equal to 1.1.668, sorry, 678. So if we round it up to three significant figures, it is going to be 1.68 meter per second. That is the final velocity of each of the particle, and that is how we will find our solution. Let's see whole of the solution. Yes, this is what our solution is, and I think you have understood that if the question has already told us to apply the concept of the work energy equation, and in work energy equation the components are, major components are change in GPE as well as change in KE. As there are two different particles, that's why we will have to find out the sum of the total change in GPE of both of the particles, then sum of the total kinetic energy of the both of the particles. Then we have applied the formula is work done by driving force minus work done by resistance force equal to change in GPE as well as change in KE. And as there is no external force acting on any of the particles, that's why driving force is 0. But there must be resistance force on Q, because Q was moving or sliding down on a rough plane. And for for particle P, there is a resistance force because P was sliding down on a rough particle, whereas Q doesn't have any resistance force, neither resistance force nor driving force. Okay. Because Q is just hangs below the plane or under the pulley. And remember, you may ask that the weight of, how was weight of Q calculated? Q was balanced using the change in GPE. Height has been calculated, and for particle P, actually it was moving down, that's why P was moving down. So height in terms of the ground, it is actually negative. Final height is less than the initial height because it was moving downward, but for Q it was moving up. So in term of the ground, the final height is more than the initial height, that's why it was positive. So I think all of you have understood the solution as I have shown. So thank you all for watching the video.